So yeah, I'll be your host today for the very first OpenLog webinar. My name is Evren Pakuschari. I'm the general manager as well as co-founder of Apeiron. We're the team behind OpenLog and a variety of other open source GIS technology. To be able to follow this webinar, obviously you'll have to be familiar with QGIS and familiar with mineral exploration, basic mineral exploration concepts. Beyond that, there is not much. If you're willing to follow along the steps I'll go through during the demo, you're welcome. You're welcome to do so. And if at some point you're not able to keep up, just be aware that this session is recorded and we will post it on YouTube, so anybody will be able to go back to the session and revisit this webinar. Now, I'll try to keep this short and as practical as possible, so we are not going to spend too much time on corporate presentations. I'll do the bare minimum here. So Apeiron is a subsidiary company of Auslandia. Some of you may know Auslandia already, but I'll present it nonetheless. It is a company that was founded in 2009 in France, and it has grown from just two guys in a shed all the way to about 40 employees now, and is the largest open source GIS company in the world. So Auslandia is known for contributions to QGIS, QField, PostGIS, and many other things, QWC2 and GDAL, Proj. Lots of open source GIS technology receives contributions from Auslandia, both in terms of code and in terms of financing and involvement in all events, live events, as well as professional organizations across the world. Now, when I mean that we contribute to these, it means that we actually develop the technology. Auslandia is not merely deploying Postgres and PostGIS databases on the basis of a client's needs. We do that, but it also is a company that is capable of developing the base technology itself. And this is basically the signature move, if you will, of Auslandia, is that it has mastery of the whole technology stack, from being able to develop at the firmware level, even bare metal in some cases, developing custom firmware for probes for the Canadian Spatial Agency, for example, and then all the way to making web portals for the IGM, the BRGM being the French Geological Survey, making web portals that allow users to consult geological maps online. And among these things, there also is QGIS plugin development, which is what we're here for. Now, Auslandia is a service company. It is mostly a company that is designed around the concept of a client enunciating their needs and Auslandia delivering on those. Now, when it comes to Apeiron is a product-oriented company. That if you ever wonder why there was a split, that is the reason. And Apeiron is focused on, mostly focused on mineral exploration time, geotechnical applications also, but mostly mineral exploration, mining industry. Whereas Auslandia is a lot more of a generalist. The overwhelming majority of Islandia's activity lies in government, as a government local. I mean, be it at the local scale, regional scale, national scale. Government agencies are the ones that are always in the need of maps. Lots of expansion on the geomarketing side of things, but the core remains a government, which provides Icelandia a solid base and a stable base and stable income, and allows Icelandia to do things like Apiron, and gives Apiron the assurance for itself and for users of its product that it will continue to exist, even if there's a bit of rough air sometimes. When it comes to OpenLog itself, well, OpenLog is a QGIS plugin that was originally designed for drill hole data visualization, is in striplogs onto the map and onto cross section, letting users visit their data, be it numerical data, categorical data, be it imagery, structural data, orientation data, having it all live in QGIS. When we made the decision to develop OpenLog, it was pretty much a completely barren environment in the open source GIS side of things. There was alternates on proprietary platforms and attempts, and I will mention here the Geoscience plugin, which was and still is to a certain extent an excellent plugin developed by Roland Hill, who's been a key factor in the success of OpenLog, as he has served as an advisor in the very early days of OpenLog. This is a quick side note. If you're a Geoscience plugin user, just be aware that beyond compatibility updates, Roland is effectively stopping development of the Geoscience plugin in favor, effectively, of OpenLog, as this was a solo project of his, and it has grown beyond what he has effectively free time to devote to, and has made the decision to just let OpenLog effectively carry the flame on this side. Now, OpenLog has been going for quite a bit of time now. There's been about well over 20 versions that have been released over time. We release new version every 6 months, every 2 weeks or something. We have about 1,000 active users at any one point in time, and it has grown over time, steadily grown over time. So we see that users actually stick with us, which we're very grateful of, as in the early days, OpenLog was not exactly the most stable piece of software. We do have to admit that. Now, over time, a number of features have accumulated, letting users explore their data, work with their data in a more advanced ways. And we'll get to, I'll give you a tour of that today. I won't be able to cover the whole lot. 2 hours is not even close to be enough now that the OpenLog has reached the scale it has. But yeah, we can display all sorts of data. We can display lithological logs. You'll be able to display numerical logs, things like XRF data, being able to take into account uncertainties in the form of error bars and display imagery. All of these things are possible in OpenLog. Now, a quick word from our sponsors. I might say, well, these sponsors that you see, all these logos that you see, are the original sponsors of OpenLog version 1. That is, these are the people that believed in our project when there was nothing but myself and a pretty brochure going around on trade shows and trying to convince people that OpenLog was needed and that it was basically there was this empty spot for drill hole data viz in QGIS, and especially given that we started doing this work about 4 years ago. At the time, QGIS was picking up strongly in the mining industry, but it was not at the stage it's at right now, where it has become effectively standard, especially for juniors, especially for explorers. Most of these sponsors actually are not sponsoring us anymore, but that is not exactly a bad thing from our perspective. It's because we've shifted business models for being purely sponsor driven to being, let's say, a hybrid between open core and what we call DOSP, which is delayed open source publication model. So if you wonder how OpenLog works and how OpenLog meets its licensing obligations in relation to QGIS, the QGIS core software license, the community version. There is a community version that is fully open source, and this one anyone can install simply by going into the plugin manager, typing OpenLog, and installing it like you would install any other plugin. And then we have extensions that add features to the base version. And these are not exactly proprietary. They're delayed open source software. So effectively what happens is that when a user chooses to subscribe to the premium version of OpenLog, they will have the most important thing that they obtain is access to these extensions. And these extensions are going to be premium only for 2 years from the point of release of that of the very first version of that extension. So there is no evergreening case here. Just because we make an update on an extension doesn't mean that it pushes back the open source, the FOSS transition of that extension. So after 2 years' time, the extension goes into the base version. And so for us, this is effectively a way of funding the ongoing development of OpenLog, and is effectively not a license. And here, well, you can see the different types. I'm not going to make much comment on those. The base version, yes, it's the base version. You probably have it already installed on your system. Solo is you're just one user. You want access to OpenLog. You want it immediately. These are per annum prices, and they are GST free. If you're outside of European Union, these are indeed the prices, and if you're within the European Union, it will depend on which country you're based in. Team up to 10 users, and you'll have access to ExploreDB online. We'll discuss that later, but this is basically the drill hole database that we package with OpenLog, Postgres database. And partner is effectively for larger companies to basically have access to OpenLog in general. We don't really count how many seats. I mean, we count them, but there is no upper limit to the seats, and there is no public pricing here because it depends on what the client is looking for as depending on how exactly they want support to be provided and whether or not they are seeking to have custom-made integrations with their internal systems. So this is the reason why it usually is packaged with some service work as well as training. I want to take a moment to thank the team and show their faces. Apparent and Auslandia are engineer-driven teams. You must have noticed there is very little marketing coming out from us. That is mostly related to the fact that we like to put the dollars that we make into developing a software. So whenever you choose to join in on the premium membership boat for OpenLog, what you're doing is that you're effectively paying these people's salaries and my own, incidentally. Well, I happen to be on that picture too, so that's fine. This is what really it does. OpenLog, even in the age of AI, even in the age of LLMs, in the age of Claude and ChatGPT and Codex, it still takes a lot of effort. It does help, for sure. It does accelerate development, but it certainly does not give us the ability to simply, have it all done by an AI. It doesn't work that way, especially when you're working with scientific software, where good enough is a good enough answer is not good enough. It has to be the right answer. And this is where humans are still very much needed. So here you see on the I'll go from left to right, top to bottom. So the grayed out person is Raphael Delhomme. He's actually our ML engineer. He's got PhD in AI, and he discusses things that fly way above my head. Vincent Larmet is the next person. He is the main developer of OpenLog proper. Then is Vincent Piquet. He is the founder of Auslandia, and also, incidentally, of course, co-founder of Apeiron, and is also a developer. He is not a out of touch CEO by any means. And when the website is down, it is often his fault that he has not done something he has forgotten to update something usually. Sylvain Beorca is our graphics designer. If you ever wonder why our brochures and every kind of marketing content that we have that involves some sort of graphics looks very unique and very not AI, by the way, it effectively comes from him. He also is one of the main contributors to the QGIS organization graphics. He is the one who designs logos for the QGIS organization, designs backdrops for their conferences and things like that. So if you've ever been on the QGIS.org website, which you certainly have, you have had to bear witness to some of his creations. Then there is myself starting, and next grayed out picture is Jean-Marie Kerlog. May his soul rest in peace. Jean-Marie has left us fairly recently. It was quite a strong hit for the team. He used to be the main developer of OpenLog in its infancy, and is the one person I spend most of my time with for well over a year, when Apeiron was just an idea, a figment of my imagination. Next is Jean Felder. He is a 3D developer and works mostly in the 3D engine, the native 3D engine for QGIS. Has made significant contributions to the native cross-section tool, elevation profile tool in QGIS. And next is Benoit Ducarouge, who contributes on a regular basis to OpenLog. He's mainly responsible for custom developments that may be requested by partners. As I mentioned earlier, large companies often request special kind of integrations with their systems, and usually Benoit is the one who's going to take care of that. Now, before we begin the demo proper, here's a number of quick links, which I will also share in the chat. You can, if you're watching, you can pause the video now if you wanna on YouTube, and these links are going to be useful for you for a number of reasons. The first one is the main page of OpenLog. This is where, if you're interested in OpenLog, an OpenLog premium subscription, this is where you can subscribe. It also lists a number of features and provides access to other links, namely the documentation, which is the end user documentation. The second link, the code itself, the code repository, as the community version is fully open source, so the code is freely available. And the bug tracker, which lives on the same repository as the code, but this is the direct link, and this is where to go if you ever encounter any issues with OpenLog as a user. Sending emails directly to me or to the contact email of Paron is, well, it's not forbidden, but let's say that what happens is that the odds that your email ends up lost are much higher than when you do open a ticket. Especially, it means that if I'm away, if I happen to be sick, somebody in the team will definitely see the ticket being the issue being open on GitLab. So it is a lot more efficient to go through the bug tracker and simply open up a new issue. Even if you have questions, even if you have suggestions, you're free to do so in that place, and that also allows you to receive notifications when there is an answer or an update, or even when there happens to be a merge request that is answering, for example, your suggestion. And before the last point I want to make here is that if you want to have the best experience with OpenLog and, in honestly, with QGIS in general, run the LTR version, run the long-term release version, which is the most stable version. You might miss a couple features, new fancy features for 6 months or so, but it is a lot easier on the mind to be running the LTR version, and we target OpenLog to be the most compatible with the LTR version. It should work with the latest version, and OpenLog works with the QGIS version 4, even though the LTR version is still 3.44. But we do recommend, in general, users to run LTR rather than the latest release. Now, when it comes to these links, I'll just share them with you. Here is the roadmap, by the way, to get the LTR. So the current long-term release is 3.44.13 at the moment, and it is what we recommend you use for any sort of serious work. I will share this link too, as well as the end user documentation for everybody to be able to access it as needed. And the bug tracker. If you ever wonder what we are up to on OpenLog, what's coming up next, and you're not subscribed to the newsletter, or I feel that in some way it was not delivered to you, or you'll be able to take a look at what we are doing by checking the milestones for OpenLog, which will include discussions around what is happening in OpenLog Premium. These discussions happen in the open, so you can have a look right now at what's going on with OpenLog version 2, what we're working on. There's more work going on with cross sections. We've implemented borehole deviation, for example, representation, expanded on bar chart projections, and a bunch of other features. So you'll be able to tell what we're up to, how it's coming along, without having to simply, either query us directly or just wait for some kind of newsletter or LinkedIn post. You can have a look at what we're up to and what we're talking about at any one point in time. If you are willing to follow along the demo itself, this last link is the important link, is the link to the test data, and this is what we will be working with, and more specifically, I will share this one. This is the data set that I'm going to be using for today's demo, which is a publicly available data set that was pulled out of WAMEX. So the Geological Survey of Western Australia's mineral exploration database that all mineral explorers have to contribute the data to. This lets us, we usually work on this type of data set because it is real world data, and instead of being synthetic data, we try to work on real data as much as possible. All right, moving on. We will be going to QGIS itself. So I'll be running this demo on Linux. It has no importance really whatsoever whether you are using Windows or Linux. It should work on Mac. On Mac OS, you might have issues with certain libraries. We've fixed that, and it should be fine in the next version, the next release of OpenLog. If there is a dependency missing on Mac, you can install it manually, and it will work fine. The reason is that we had this issue on Mac is that we have so little users. We have a very small Mac user base, and they're not very vocal. They usually tend to fix things by themselves and never tell us. And because we're not, obviously not Mac users ourselves, the tests that we run sometimes don't have good coverage, as we ourselves, in all honesty, are not very familiar with the system. Obviously, if you encounter an issue on Windows again, I'm going to direct you to the bug tracker. Let us know, take a screenshot, copy the error messages, anything that can help. And if you ever need to open up one of these issues, another very useful thing is to copy paste the content of the help about window. And there's this copy to clipboard button, which will be very useful for us, as it will tell us exactly what version of Q you're running and all associated dependencies, and potentially other plugins that you're running on on Q that might interfere with OpenLog. All right, so here we'll be working on a West Australian data set, as you will have a bit of trouble to see. I've had to cheat a little bit with the symbology for the DTM. This is a maps and global terrain. It's a global DTM dataset that anyone can add to their project. So first step to get involved with OpenLog is to head to the plugin main menu, and from there you'll be able to type in OpenLog. And this is where you install OpenLog, even if you're a premium user. It doesn't matter that you're a premium user or a base user, that you're here just to have a look, or just for curiosity's sake, or this is the 50th time that you're installing OpenLog. It always works the same. We strongly discourage users from installing OpenLog from the code repository or from the plugin repository on the qgis.org website. It's not that it doesn't work, it's that you won't have any dependencies that are being packaged in there, so you'll be responsible for installing all dependencies manually. Which also means that when you download an update to OpenLog, you'll have to update dependencies accordingly, according to the requirements of OpenLog. So it is a lot of work, and is mostly something that you do if you're willing to contribute as a developer to OpenLog, which is possible. Contributions of this kind are welcome. It is open source software. It is not locked up. Just because it is mostly developed by your parent doesn't mean it is completely locked up. If there's something that you've noticed that you could improve, you're welcome to do so. And of course, fork OpenLog and then put a merge request up, and we'll review it. And if it's fine, then we'll gladly merge it, and you'll be in the indulgence for that release in the change logs. So as you can see, there's been we're nearing 18,000 downloads. Don't let it fool you. I'm not here to make OpenLog look more impressive than it is. There ain't 18,000 users of OpenLog. It's 18,000 downloads of OpenLogs total. As I mentioned earlier, we have somewhere between 800 to 1,000 active users at any one point in time, which already is quite a lot when we consider this a very niche software, and basically tells us that we should keep going. Now, once you've installed OpenLog, there's the OpenLog main menu that will insert itself at the very top of your QGIS window. And the very first thing to do, if you happen to be a premium user, or even if you're not a premium user, actually, it is still useful, is to click on the settings menu. And here, there'll be, it will tell you which version exactly of OpenLog you're running. By the way, if you're running an outdated version of QGIS or an outdated version of OpenLog, OpenLog will tell you. On installation, OpenLog will complain and tell you. You could be running a newer version of OpenLog. If you had QGIS up to date, you'll basically see a message of that kind. From here, you'll be able to, from this settings window, you'll be able to click on the help, which will drive us back to the end user documentation. I've already shared that link in the chat. You're also able to subscribe to the newsletter from there. If you haven't done so at the point of install, when you install it, you get a prompt to subscribe to the newsletter. Our newsletter is 3 to 4 times a year. It basically, the only thing that we package in there is when there is major changes in OpenLog. We are going to attend some a large scale event. We are launching a new project, something like that. It's not a weekly thing. You get something every 3 or 4 months. And it's a single page and contains no tracking. This is also where you're able to report an issue. This will drive you straight to the bug tracker that I've already shared the link to earlier. And we have a reset settings button if you happen to have messed up the plugin settings somehow. You can just reset it all if if need be. Then there's a bunch of other options that we are not going to discuss here at this point. It's unlikely that I get to this point in the demo. If you're a premium user, you'll be able to input here your credentials on this page, and then log in. If you're looking to join or manage your account, this is also where you're able to do it. If you click on join, it will basically drive you to the OpenLog main page, effectively the apeiron.technology/OpenLog page. An account will drive you straight to the account management page, where for most users it's a place. For solo users, this is where you can download, for example, a PDF of your invoices and check how long your subscription runs for, and so on and so forth. If you happen to be a multi-seat user, this is also where you can handle the seats. About being a solo user or multi-seat user, when you're a solo user, the subscription is node locked to a machine, but we will let you swap it to another machine. Just get in touch with us. Either you can send an email, or you can open an issue on the bug tracker and tell us that you want to reset the seats because for example, you've changed hardware, and we'll do so. There's no problem. We won't have you buy another one. Basically, the solo version is you have a subscription for a single seat, regardless of where it is. We don't really mind. And of course, you can have a look at the terms of service. You're free to take a look at that. We don't mind, actually. These are not actually fine. This is not actually fine print. We don't mind having it. We don't mind having people read it. I think we have. I mean, I want to believe that we have the most generous TOS that was ever laid out in this industry. Effectively, it is mostly a matter of who owns data. You own your data, and we make no claims of any kind on that data, including using it for training AI. So we don't do that. We don't spy on you. There is almost no telemetry, except for the fact that you're logging in with your account. And if you're a free user, there's effectively no telemetry in OpenLog. And when it comes to what you're allowed to do with the software, you're allowed to do whatever you want. You're even allowed to modify the code. The only thing that we place a restriction on is support. We will not support a modified installation. We support what we deliver. We don't support your custom-made version of OpenLog for obvious reasons. We'd be completely unable to actually do that work. On the right side, there is a table that you must have been looking at for quite a while. This is the table of all extensions, and this is where you can select extensions for installation. You can select them all, deselect them all. You see the latest version, the installed version. If you happen to have a version installed, this table will populate itself even if you're not a premium user. And the DOSP date is the point in time, tells you the point in time where this extension will be contributed to the base version of OpenLog. The moment it ceases to become a premium only extension and becomes just a base level extension. When it comes to that, I'm pretty sure some of them are going to, this is going to happen. Depth ticks, azimuth sorting is going to be, for example, fairly soon. You'll see those in January. In January, there'll be a number of extensions that will be contributed to the base version of OpenLog. This will be the very first round in January 2027. So that's the point in time where you'll be able to cast judgment on whether or not we act on our word. Moving on, OpenLog help goes to the end user documentation. The very first step we'll have to go through when working with OpenLog is going to create a database or connect to an existing database. We're going to assume you do not have a database at this point. And so we would go to database create, and we have two options, ExploreDB, SpatiaLite. ExploreDB is a database schema that we provide. It is fully open source. We provide management services for it, hosting services for it, but the database schema itself is fully open source. You want to deploy it on your own server, you can. You want to deploy it wherever, whatever technology stack, whatever infrastructure behind it, you can. It is Postgres 14, Postgres 3. These are Postgres 14 is really the bare minimum for ExploreDB. Its client-server configuration handles multiple users, concurrent access, user privileges, distinction. It is very powerful, but it is more suited for cases where there is a large database that a significant number of users are contributing to, and also a significant number of users are only supposed to consult the data, to be on read only. So this is more like the enterprise database that we provide. SpatiaLite is a single file. It's a .db file. It is a spatial extension to a SQLite. It is similar to GeoPackage, but is more powerful when it comes to spatial algorithms. But it is similar to a GeoPackage in the sense that it is a flat file on your file system, but is still underneath structured like a database. So your data is not just sitting in a bunch of CSVs, it is actually properly packaged, and we can convert a SpatiaLite to ExploreDB and back. What SpatiaLite is useful for is to be packaged in, say, a report, to be packaged into, say, an investor's leaflet, to be to work solo to get some thing on your screen very rapidly. This is what I would recommend for this purpose, and this is what we're going to be using for this demo. So if I click on that, I can simply just head over to the desktop and save it wherever I want on my system. So I'll be saving it on desktop, which is a very bad idea, by the way. Don't do that if you're actually working with real data. You know, I don't mind if this database disappears at a later point in time, but I really suggest you don't actually save critical data on your desktop. It's a bad habit. Now, the one thing you need to be aware of with a DB file is that whoever has access to the file, as far as the file system is concerned, is God to that database. They can do whatever they want with that database. They're an admin, they're a super admin to that database. All right. It is not something that is it is not something that is going to have any concept of user privileges. So it is fine to work as a solo consultant. It is fine to work usually with that in small operations. As soon as you're starting to have 4 or 5 people that need concurrent access, you must move to ExploreDB. You can do it yourself, find yourself a database manager, or ask us to do it for you. That's fine. But you will move to ExploreDB. Do not use SpatiaLite as soon as you've got more than 3 people involved with the database. This will blow up in your faces, and that's not what it was designed for. It is designed to get something quickly on your screen when you're working by yourself. It works also fully offline, of course. And OpenLog in general, by the way, works offline. Even the premium version, it will work offline forever. I mean, forever at some point, however, you'll be missing the updates, obviously, but it will work forever offline. There is no such thing as you need to connect once every week or something like that to keep it up. It doesn't work that way. Even if your subscription run out, whatever you have installed on your machine will keep working. This is, by the way, a general statement. When you subscribe to OpenLog Premium, what you've paid for is effectively the extensions in a certain state. And even if your subscription runs out, for the OpenLog Premium capability does not vanish from that machine. It simply ceases to be updated. So they effectively kind of sort of perpetual. I mean, they're as perpetual as QGIS will allow it to be perpetual. At some point, QGIS itself will be updated to a point that makes your old extensions incompatible with it, effectively. So once we connect or we've created a new we create a new database, a number of things happen in the layers widget. We have two layer groups that are going to pop into existence, effective and planned. Discuss this at a later point in time. Basically, it's the distinction between what was planned and what actually happened on the field. Color layer, that's a point layer. Trace layer, that's a line. That's a line layer. Same for plan, color, plan, trace. The color table will pop up on the screen and will be empty, as it should be. We do not populate new databases with junk data for demonstration purposes. That's not what we do. Your database comes out clean. So obviously right now we don't have anything of value in our database. So the next step is going to head over to data and start importing. And we're going to be importing tabular data. We could also import AGS, the data out of AGS files. AGS files are geotechnical files. They're self-contained. They contain effectively assays, color information, survey information, all within one file. They're similar to LAS files that are used in the petroleum industry, but in the geotech world, mostly UK. So anyway, for tabular data, the sort of standard will be importing color data, and the very first window you will be met with is going to be a metadata prompt. So effectively, we're going to specify a person. I'll use my trigram and a data set, and I'll use web1. So this is for traceability purposes, effectively for accountability purposes, to know who imported this and what data set was it a part of. Then hit next. And here we have a CSV importer. You've probably seen many of those in your life. There's two options here. We can navigate to a CSV file, or we can actually pick data from a source table. If you wonder, how do I import data out of an Excel spreadsheet? How do I import data out of GeoPackage, out of a shapefile, out of another database? The way you do that is that you pull the data into the layers as a new layer in your project, and you'll be able to access it as a source table from this window. Here, I'll just be getting to I'll just import this data out of a CSV file. And there you go. Now, once we've selected the CSV, we can define if there's X number of lines for the header, if the encoding is right. Usually UTF-8 is fine. We specify a CRS. This is Western Australia. Almost everything is going to be GDA 94, zone 50, zone 51. And this is actually wrong. This is zone 51, not zone 50. We can specify a DTM. It is not mandatory, but you may specify a DTM. And then the next in the simple data section of this importer, what we see is the content of that CSV file as parsed according to the rule set in the file format. This is where if it's not comma separated, but it is a semicolon separated, tab separated, space separated, and the text qualifiers are whatever, the single quotes or double quotes. This is where you can make these define the formatting for that CSV file. If you're importing a CSV file, if you're importing directly from a source table, you won't need to bother with any of that. This section actually will disappear. It will vanish if you are importing straight from an attribute table. Then here we'll have to match these columns as passed out of that CSV file to what the database expects. So the database expects a whole ID, which must be a unique ID, expects an easting and a northing. These must be UTM coordinates. That means they must be meters. We don't work with geographic coordinates. At this point, we've considered it many times. No user ever thought, well, let's actually do that. So we've gotten, we need it. No one ever said that they needed it. So we haven't gone around to implementing that at this point. So here what we'll do is that for the easting, we'll take best X and best Y, as this is how they were the nomenclature of the company that put this data out back in the day. And elevation, there's a number of options here. We could pull the elevation for these colors, the colors being the points at the surface, they're unique. Each one of them being a unique entity. We could pull the data out of a DTM. This is useful when for planning purposes. We could set it as a constant. It could just be left empty, which means it's going to be zero, a bunch of zeros. Or we can pull it out of, well, the file itself, and we have a base Z here. So that is what we are going to do. EOH stands for N of hole, which in this case is actually nomenclature as total depth. It is the total length of that drill hole. Then we got plan east, plan north. So this is useful when there is some kind of discrepancy between where a drill hole. All right, so I assume that you can hear me. You can hear me well. Now, okay, we're back into the game. Where was that? Yeah, so when there is some kind of discrepancy between the planned implementation of a color and what actually happened in the field, that might happen because of logistics, might happen because of topography. Sometimes you're right on the edge of a cliff, didn't plan for that, and the drill rig needs to be set a couple meters to the side, and that is going to alter the coordinates. And when looking at horizons that are maybe a couple meters thick, this will significantly alter the geometry that you're looking at on the ground. So this is why we have made this distinction. Now, in this case, I'm just going to cheat. I'm just going to say, now, by the way, the planned version are not mandatory. What is mandatory is to have real holes, but the planned version is not mandatory. But yeah, I'll just be a cheat, and I will. Actually, you know what? I will take it from the DTM. That's what I will do. I'll say we've implanted it exactly. We've implanted every hole exactly where we set out to implant them. However, the elevation was kind of unknown, and we used the DTM for that planning, and same for UH. And then we are going to get an UH and a dip and an azimuth. Now, the dip and the azimuth are the color orientation. It is what we, as far as we're concerned, we consider to be the plan orientation
from that for that hole. And on that subject matter, OpenLog can handle any hole geometry. Your drill holes can go upwards, they can go downwards, but we use negative dips down as a convention. And when it comes to the azimuth, we use geographical convention. So 0, 360 is the north, and it's going to be rotating clockwise from 0 to 360. So 180 is south, and 90 degrees is east, 270 is west. Now, when it comes to dip, negative dips down. 0 is horizontal, minus 90 is straight vertical, and plus 90 is straight down. Sorry, it's minus 90, and straight up is plus 90. Once we've done all of these, what we call column matching, column pairing, what is going to happen is that you will see what is about to be inputted in the database, and you'll have, if you've done the job right, you'll have a bunch of green check marks over at the top of every column. If you happen to have more metadata associated to every single hole, such as the company that drilled the hole, the company that surveyed the hole, the geologist that was responsible of the rig at for that hole, the dates, anything. This is where you can use this plus button here, and you'll be able to add as many columns as you need to. So this is part of OpenLog and ExploreDB's commitment to the concept of being flexible. We let users, we have a base number of requirements when it comes to your data, and then we let the user tell us about their data and build a database accordingly as they are expanding on the description of their data. And then we won't spend too much time here, as there is going to be a it's too quiet. Okay, so I'll try to fix that. Yeah, it's not the same headset. So this should improve things a bit. Should be a bit better. I pushed it as far as I could. All right. When it comes to that, and then you're also able to remove a field at any one point in time. All right, hitting next. Hit next tells us what is about to happen. We're about to import about nearly 400 colors. Click finish, and there you go. We've got the color table that pops up again on the screen, and we've got all our tools in there. I'm just going to click the color layer. I'm going to Control A and going to zoom to the selection, and there we go. And now you get to see why I had this very weird setup for my color table on the DTM, is such that we actually get to see something on this one particular data set. At this point, there ain't really much to do with this, apart from the fact that we can already, that's what I like to do with small data sets. The data set is very large, it is at your own peril. I'm just going to select a layer, hit Control A, right click the canvas, and I will click Desurvey, which by the way, I can also do up here in the main menu. I'll click Desurvey, and we haven't imported a survey table, but we technically already have a single orientation that was associated with every single hole. So we are technically able to generate 3D geometry already, even though it is obviously going to be a bunch of straight lines. But we can already see that we've basically gone through that step, and we now have these holes projected onto the map, an orthogonal projection onto the canvas. There are dashed lines by default, and that's because it is considered to be the planned geometry and not what actually happened, because we haven't imported survey information. The next step usually at this point is to go back to the import and import survey data. So that's what we'll do. Again, we have to specify a person in a data set for the import, and it works on a dictionary. Once you specify the person, it is added to the dictionary. Once you specify the data set, it is added to the data set dictionary, and you can just pick from the dictionary. You don't have to rewrite that and re-input that every single time. Now that you've seen the previous importer, you'll be familiar with the second importer. We made it such that all importers basically look the same. And here I'll just go and get the survey information. And it's going to be so the no duplicates one. And in this case, there's a number of options at the top that you need to be mindful of. You might be willing to invert dips. We use negative dips down. If you're using opposite convention, you can invert dips in that with that checkbox. You're also able to update the end of hole. In some instances, I know people have very strong feelings about that, and I honestly don't mind. Some instances, some users have repeatedly expressed that they needed the length of the hole to be updated according to what the survey measures. Some users don't want that because they tell us, yes, that's well, you can do that, but what is measured with the survey is going to be a couple meters shorter than the actual length of the hole. I agree with that. It's not my effectively in my jurisdiction to determine whether or not you want to do it, but here you have the ability to update the EOH on the basis of the survey information that you imported for the hole. Okay, so Dan is raising his hand. Well, you do have the permission to talk, Dan, if you are willing but you have to unmute your mic because you've had the permission to talk for a while. All right. Moving on. So same thing. You can specify the encoding, whatever number of headers you have. We're going to associate columns in the CSV to what the database expects. In this case, the database is very strict. You cannot add additional data in your survey table. We might do that in the future, but so far, no one has ever expressed the need for that. And about what we need to match, we need to have a whole ID, dip, azimuth, and length. They're all obviously different azimuth of degrees. I've already specified the convention several times, and obviously depth is meters. If you ever wonder about the units, we always use SI. Length is meters, weight is kilograms. We use the SI, the International System of Units. And even when you do import, say, imperial measurements, they will be ultimately stored in the SI equivalent in the database, and you'll be able to display them imperial, but they will be stored SI. Next step again, we have these checkboxes. We're going to import about 5,500 surveys, survey entries, which means we have around 12 points there for on average. Not every single hole has got survey information in this data set. So this is not high-res survey by any means. OpenLog can handle, QGIS, OpenLog, and ExploreDB can handle large amounts of data. Just be aware that when you're using Spatialite, it is not designed for very large data sets. So we've had users come in and import 30,000 holes into Spatialite and very high-res survey data and downhole data. This will not go well on Spatialite. That's not what it's for. You will have to have a proper database if you are working with this sort of very large data set. So here, I'm just going to run the desurvey algorithm another time. The reason why it does not do that automatically is related to what I've just mentioned, that we do not really take into account, I mean, we consider that you might be importing a very large number of drill holes or drill holes with very, very high res measurements. And that means that we might end up with performance bottleneck. So usually the way desurveying is run is that you're going to select any number of colors in the color layer and then run the desurvey manually. Once it's done, stored in the database, you don't have to do it again unless there was an update to the survey data itself. But normally you don't need to do that. And the reason for this is to not have your computer just be left hanging, as this is what happens to one of our esteemed users at Norgold at the time. He imported 30,000 drill holes, and then it doesn't work on a specialized database. Now that we've imported these surveys and that we've desurveyed, we can actually take a look and say, for example, we can just zoom onto this one hole, and we get to have to see the difference between what was the color orientation and well, what actually happened was measured. So we can have a look at the deviation. I will not be able to display the whole deviation. This is something that we are about to release, but we've done that. We've done that work. We have got a rows diagrams to actually take a look at the deviation. If you want to have a look at survey information for a color, we can select the color and right click, and we could edit the survey or edit the color. We could alter information about that color, its location, any information really. We'd be able to alter with this one tool, and then we can also edit the survey information. In this case, we've got a bunch of measurements. We've got 31 measurements in the effective section. We'd be able to add some, remove some, edit some of these measurements, and we've only got a single one is planned because that was just the color survey that the color orientation that we had imported at the very first step. Now, this is useful in and of itself, but we're looking to have, we'd like to have a look at data. It's nicer to have a look at data. So again, we're going to go back to data import, and we're going to import downhole data. OpenLog does not make any distinction about your downhole data. Everything from our perspective is downhole data. We don't consider whether it's lithology, whether it is assays, whether it is geophysical measurements, whether it is this, whether it is that. You're going to tell us what your data is like from a structural point of view, from a scientific point of view, not from a human categorization point of view, which is going to be your responsibility when you're going to import the downhole data. So I'm just going to click there. Again, I need to specify person in the data set. And here we are met with a slightly different menu. We need to either pick an existing table, which there is no downhole data table at this point, or we can create a new variable. So we can create a new table. So I'm going to be very, I'm going to be extremely original in my naming conventions. I'm going to import lithological data. I just called it lith, and the domain, we're going to specify a domain and an extent. The domain is related to there's two options for domain, this time and depth. We support temporal data. This is useful for things like measuring activity downhole. And if you ever wonder what has anything of that got to do with mineral exploration, well, Orano is a sponsor and one of the original sponsors of OpenLog. So yeah, they do measure activity. They're uranium, so measuring activity over time is a thing for them. Domain, in this case, is going to be depth domain, and distance can be discrete, extended. Discrete means these are point measurements. Extended means they're interval measurements. They're from to measurements. Discrete means they're point measurements. In this case, it's going to be extended. They're from to measurements. They're going to be I'm going to be importing also itself, which is, at this point, we're very familiar with it. Let's put down data, measure geology, and I'm going to be importing the geology no duplicates data set. And here again, same thing, we're passing a CSV, and now we need to match it to what the database expects. So the database expects a whole ID. The database expects depth, min, depth, max, which is from and to. The reason why we don't call them from and to in the column naming convention is that it depends. Environmental scientists, geotechnical engineers have different naming conventions. Mining geologists have different naming conventions than petroleum. And this means that we try to find naming conventions that were sort of neutral. And that's the reason why we just have depth, min, depth, max here. Again, units are going to be meters. We can't change the type here. And you could specify no data value, by the way, for that. That's very odd if you happen to have a no data value for your from to measurements, but you are still able to do so. Now, at this point, we are not importing anything. At this point, there is no data in and of itself. There's support for the data, but there is no data. So in this particular case, we need to add columns. In this case, I'll add 2 columns. And what I'll do is that I'll map list one code in this case. And as I do so, the imported data section is going to update itself and get a big red X mark and a bunch of nans and a bunch of angry red cells. What this means basically is that the type associated to the column I'm attempting to import is not right. We support numerical, categorical, nominal. Nominal is text, date, time data, imagery, and polar, as well as spherical measurements. In this case, it's telling me it is not numerical data, which makes sense. We can see the left one code column here. There is no numbers in there. They're just a bunch of alphanumeric alpha codes, actually. So I'm just going to place categorical. And now all's well that ends well, rather starts well, hopefully. We are going to have that green check mark, and also we have a category section that popped up. And this category section basically is telling us of the creation of a dictionary. Categorical data in OpenLog, I mean, ExploreDB really, but in OpenLog, let's say, is based on a dictionary. If you don't have a dictionary, no data is going to be imported. So when you, at this point of an import, the very first time you're importing data in, you need to make sure it is the default value, no, but you need to make sure that you're on append, not on restrict, not on remove. Append means that every newly discovered entry in the file that is going to be imported is going to be contributed as a new dictionary entry. What this means is that if, for example, I selected another option, nothing would be imported because at this point in time, the dictionary is empty. So we are using the data set itself, we are using the CSV itself to populate the dictionary. Now, a dictionary is useful because it basically allows to control what comes into the database, and the other options are restrict. It means it will ignore every line in your CSV that does not that has a mismatch with the dictionary, and remove means it will kill the entire drill hole. The data that is associated to the drill hole in general will just be ignored. So it couldn't be multiple lines. So anyway, in this case, we can have append, and we can add also, if we wanted to, we could add comments, for example. We can add comments. And again, if I do comments, it's going to tell me, no, these are not comments. And say, yeah, that's right, they're not comments. It is just text. And again, here we'd be able to technically we'd be able to specify no data. If we were importing numerical data, we'd also be able to specify units, but here we can't specify units for text and categories. There is no units. The concept of units does not apply here. And then we'll see sometimes there's comments, sometimes there's no comments. We can handle empty fields. That's fine. OpenLog handles empty fields. All right. And then hit next. We get some a report of what is going to happen from database, from a query point of view, from a SQL query point of view, that we're going to create this table with all these different columns, all these different fields that are the mandatory fields, and these are the custom fields. And this is going to be another field that is going to be added to the dictionary table, which is also a permanent table. And explicitly, then going to hit next. Tell me I'm about to import 12,600 data entries over 328 colors. So we know that not all colors have got a log, a lithological log in there. Now it's going to take a bit of time, mainly because I'm running this on a laptop and I'm streaming it. So it's a bit difficult for this machine to do that import, and we are importing this in a single flat file. When we're importing it onto XORDB, which is the Postgres version of the same database schema, it is almost instant, effectively. It is, as Postgres has multi-threaded capability, we're able to import the data a lot faster than what is on Spatialite. When it comes to next step, by the way, if you are at any point facing an issue with the importer, don't hesitate to, I forgot that. One point I forgot about the importers is that there is the possibility, it was in the bottom left corner, there is the possibility, once you've set up an import, I'll do it for the next import, I think, there is an option to save an import profile. So if you have very complex data that you need, a complex table that you wanted to import, and you don't want to have to parameterize the importer every time by hand, you can save import profiles to the database or as a JSON file, which is a text file that is human readable and editable. So there you go. We've imported the data. Nothing happens on queue. Again, there could be a tremendous amount of data that you imported in, so there is no reason for us to do anything on the screen. But what we'll do is that I will right-click the canvas, the backdrop of the map, and I will display that data. You can also do so from the main menu, display that data. The panel, depth data panel will dock itself to the right, and again, will be left empty, as you might have God knows how many data series downhole for every single hole. So it's not going to populate itself with anything by default. So to have any sort of data show up, what we're going to do is that we're going to click this button, which is the add button. So that's in the top left corner of the depth data panel. Click add, and here we'll have a drop down. It will show a drop down list with all the tables. In this case, we only have one at this point in time. Click left, and then we have two variables downhole. So I select those two, and it's going to update the striplog viewer to the side with the data. Now, if you wonder where did the color and the patterns come from, by default, it just does this by completely randomly. It's going to try and generate maximum contrast as far as the patterns and the colors go, so that you get to see something. But we don't have some sort of smarts out there that allow us to tell what should be this and what should be that. We tried to do that, and we realized that it didn't work. Every company has got their own conventions, really. We like to pretend we have some sort of code naming convention for rock sites. That ain't the case. It is very dependent on the commodity that is involved, the stage, exploration stage that we are. It varies too much from company to company. So in the end, we gave up on that. So anyway, we have this one striplog. We can have several of them up at the same time. By default, they are stacked on top of another. We can use this transpose button here to remedy to that. And you can have as many as you want. We can choose to hide, say, for example, the comments. I'll hide the code. In this case, we won't see anything. Or the opposite. In this case, we have a tiny bit of text. Yes, if you have text, we will deal with it gracefully when it turns out it wouldn't fit. The logs are going to be synced. You can pan and zoom onto them. There's a bunch of options that we have access to in this selection tree on the left side of the panel, and allow us to, first of all, choose to display or not the category. Let's say I already know what each pattern and color means. I don't need the written category associated to it, and that's fine. You can get rid of that. You could also get rid of the pen, for example, if you want something a bit leaner. There's options for altering the titles. Let's say you don't want the series name, you only want the color name and the column name. We can do that to try and make it a bit lighter on the eye. There's options, so we can add a minimap, which is going to allow us to navigate the data more easily, more efficiently, if needed. And the styling, if you've worked on the styling, of course, before I get to that, you can alter the pattern. We ship USGS patterns, mainly because they're open data and also because they were SVG. You can have your own patterns. They just need to be SVG format. And we, for example, integrated USGS and AGS also. USGS and AGS patterns are shipped packaged with OpenLog when you install OpenLog. So those are effectively, in a sense, free. And then you can have your own patterns. Just make sure that it is VG format. They need to be vector format, because otherwise, when you're going to be zooming in and out onto one of these logs, it's just going to pixelate. So to avoid that, we don't allow raster patterns to be used with OpenLog. Here you'd be able to alter also the color and the scale also for the pattern, and you're also able to alter the key. Now in this case, it doesn't really make sense, but there was lith1 code, there was lith2 code, there was lith3 code, there was weathering, there was other types of information in that CSV file we imported data from. And I'd be able to swap the key and state, for example, I want the color or the pattern to be indicative of weathering. And you'd be able to do that cross-field symbology. Make it fetch the pattern, indicate the rock type, the color indicates weathering, or the opposite, for example. You'd be able to do that. As long as it lives within the same table, you can do this cross-field symbology by altering the key. And if you want to change the patterns, then here we can double-click and you'll have a bunch of patterns that you can choose from. This works on Linux, works on Windows too. Normally, on Windows, you might not have an SVG thumbnail generator, but this is something you can install pretty easily. I'm not sure Windows 10 doesn't have one packaged from the natively. And Windows 11, I'm not sure if they have an SVG thumbnail you are integrated with in the Explorer. Now, at this point, we're also able, to save this file. We could save this file to the database, for example, which is what I'm going to do. So now I've basically saved this file to the database, and it means that whatever work I've done, the one person that has done all the work to make sure that the right code matches the right pattern, matches the right color with the right key, all that, it can be saved to the database itself. It can also be saved to a JSON file. And of course, if it can be saved to a JSON file into a database, it can be loaded from a database or from a JSON file. And it can be merged in case you've made alterations to an existing style. So if I wanted to load it from the database, I have to, well, in this case, it ain't going to do anything. There's a single style and it's already saved in the database. It just reloads the same thing. But if I want to load it from a JSON file, obviously it's going to open up the file Explorer and tell me, well, and I have to tell where that JSON file is located at. When working with the selection tree, you'll be able to add and remove fields as you like. So in this case, I'll remove the comments. Not interested in the comments, so I'm removing them. I haven't removed anything from the database. This is only from a database perspective. I've chosen to remove it from the selection tree because I'm not interested to be working with that. The main reason being that most holes don't have any comments in this data set. So there often ain't much to see. It was just for demonstration purposes. When it comes to numerical data, we are going to be importing numerical data now. And we're going to follow the same steps. Import data, import tabular data, downhole data. In this case, same person, same data set. I'm just going to create a new type of a new table. In this case, I'm going to call it XRF. So again, I'm very good on spoilers here. So it could be depth, and I'm going to cheat a little bit. I'm going to say it's discrete data. I just want it to be discrete. The XRF measurements are technically intervals. In this case, they're 10 centimeter intervals. But then I just want to import it as discrete. So I'll just use a single field instead of two. XRF set discrete. Next, and the next thing next is we'll do the same as we've done earlier. We ended up here. Test data. And there we go. Here we'll be able to do the same thing we've done with the lithology. So I'm not going to spend too much time here. The main difference is that we only have a single depth column instead of depth min, depth max. Instead of a from to, we have a single column. The actual data set has got a from and a to column, but I'm just going to be cheating my way into importing it in as discrete data anyway. Pull in aluminum and let's pull in one silica. We could specify the unit here. In this case, the unit would be percentage. Given that the percentage, you don't really need to specify it. A percentage is not exactly a unit. It actually means it's unitless. You're raising your hand. Can I ask a new? Yeah. If you're willing to speak, Damien, you need to unmute yourself. So you've muted yourself. So I've given you the ability to express yourself, but you're muted yourself. Or you can also type into the chat. There's no worries. I'll answer the question if you have any. So anyway, here I can specify units. Again, I could specify no data for numerical data. It usually makes more sense. I can do a -999 For example, this is something that is fairly common. There is no such thing in this data set, so I'm going to do that, but this is where to be able to do this, and it is where, well, this is the case where it usually happens. This one, I'm going to specify the unit in here. I'm going to be doing sort of nonsense for the sake of this demonstration. I'm going to say these are watt per square meters. Doesn't matter, but this is a demonstration to tell you how you would input this type of data. Does it make sense? This is XRF with this little percentage. They're as reliable as, you know, XRF handheld measurements are. But there you go. I'm going to pretend they're percentage, which is okay, and then they're watts per square meters, which is not okay. Don't do that. Next step, when you import numerical data. By the way, if you want the name of your columns to be something different, this is the CSV column. You can alter these names. You can have whatever name you want. Yeah, you could. I'm just not doing that because I'm lazy. When you're importing numerical data, there's going to be two subsections that are going to show up in the importer. And I'm going to hide this so that we can actually work with them. And actually also even hide the column definition. There's uncertainty and detection limits. So uncertainty means that basically OpenLog supports the notion of error bars and also box plots. So you have the ability to import an interval. Basically, it just basically means it's just a single number. And it means that if you have a measurement of 10, for example, and you tell me that you have an interval of 2, the error bar will go from 9 to 11. And then there's boundary pair. Boundary pair means you actually are defining the interval explicitly. So if you have a measurement, say, of value 10, you can tell me lower boundary is 5.6, upper boundary is 13.2. And that's how you do it. So you need 2 additional columns instead of a single additional column. And boundary quad is for the box plot. You need 4 measurements, and you specify them explicitly. So you need basically the inner boundaries and the outer boundaries to be set. And on the side here, there's a small diagram that is going to tell you what is what according to these columns here. There you go. I'm going to be, what am I going to do here? Do I import this data with, by the way, with the column definition? Yeah, the percentage, right. When you're importing percentage, the uncertainty is not going to, you're not going to be allowed to have this type of error bars. The reason is that you have a bounded system. You're bounded within 0 and 100. So your error bars could be out of the 0, 100. For now, we've placed that restriction, and this is the reason why only Silica is allowed to have uncertainty. Now, in this case, about the uncertainty, I'm just going to specify an interval. And, oh, I was wrong. It doesn't matter. For Silica, I specify an interval. And I'm going to be a bit cheeky, and I'm going to use Silica itself. There is no uncertainty measurement in this data set. I'm going to use Silica itself. It's going to be nonsense, but it's going to allow us to actually see the error bars. So if you do have this data, you'll know that you're able to work with it. Detection limits are kind of a similar thing. Detection limits, however, are about the device. Both are about the device. Uncertainty is how reliable your measurement is with the upper lower boundary. Usually it's a 95% confidence interval, but it can be something else. Detection limits are different. Detection limits are about what your device can and cannot do. It's not about repeated measurements, quality of calibration, or things like that. It is, or drift, it is about this device cannot measure anything below that or anything below that. Anything below a certain value, anything above a certain value. So, for example, if you have a magnetometer, I very highly doubt your magnetometer can measure a field of, say, 10 Tesla. No, it's not. And I think you should not be staying near a field of 10 Tesla. That's, I'm pretty sure, really bad for your health and probably very bad for your electronics. So what will happen is that your magnetometer will saturate and you'll get an error message on it, and that's because you've gone beyond its detection limit. And it also has a lower detection limit, so something like 10 minus 36 SI. No, it's not going to be able to measure anything like that. And you'll just end up in the noise, and it's not measuring anything useful. So you can import those values, which usually are found in the user manual of whatever acquisition device you are using to collect the data that you are looking to import into an OpenLog. So this usually is not related to how many measurements you've done, the quality of state measurements. It's related to the device itself, and it's supposed to be something that is sort of a constant, at least a constant in relation to the measurement device. If you've changed measurement methods or acquisition devices for the same variable, you can make that, it will work in OpenLog, because OpenLog treats this as yet another column. So you could have several generations, say, of magnetometers, and you'd be able to import custom detection limits for every entry. We're not going to do that in this case. Again, next, and we're going to be importing this. When it comes to numerical data, there really is no practical limit to how many series you may import into a table. So if you had, say, hyperspectral data, data on a very large number of I don't know what to do in this version. So lower hand. I'll lower your hand. On a very large number of, if you had very high dimensionality data, you should be able to import it without any issues. It might take a bit of time if you're running Spatialine, but you'll be able to import it fine. All right, doing its job. Yeah, we'll get that fairly soon in there. Well, by the way, what it is doing right now, it was not just importing, it was also validating the data. So that's why sometimes it takes a bit of time, and it is running only on my laptop. So again, we've got our data, and again, nothing happens on the side panel, and nothing happens for good reason. Nothing happens again because we might be importing, especially XRF data, this data set has got like dozens of fields. It could just suddenly try to draw 12 fields times 2 as we're looking at 2 drill holes, and that would be 24 graphs trying to pop up on the panel, which will work, but it will leave your machine hanging for a while, so we just don't do that. Again, we're just going to add it, and here we have XRF, and we have aluminum and silica, and just going to click on that, and it's creating default configuration, and it's importing it, and we can see my cheeky error bars. I'll get rid of lithology for now, so that we can focus a bit on numerical data. So first thing is that yes, we do have error bars, and yes, these error bars are exactly proportional, 1-to-1 to the value, to the measurement itself. So this is perfectly, there is a perfect correlation between variance and the mean. Anyway, we're going to be able to do a number of things with numerical data here. We are going to be able to, for example, change the color of the line, change its width, make it, say, a dashed line, and there you go, I have a dashed line. We can choose to show the point measurements, and again, we can alter the symbology of the actual measurement points. I'm just going to get rid of that. We are also able to have a grid. We could apply a grid to that, and the grid can be log scale if need be. Log scale usually makes sense for, well, log normally distributed data, such as mag, sus measurements, for example, are log normally distributed. So this is what it makes sense. There's again the option for a minimap, which lets you navigate the data more easily. Again, everything is synced. Yes, we can rearrange them. Apparently I can't rearrange those. We can rearrange. Normally, we are able to rearrange those. I can sort them by color. I can sort them by source. I can sort them by location, X and Y coordinate. Right now, I'm just going to sort them by, we've got a little bug. I have to write this one down. But basically, there's different options for sorting. Again, we can save the style to database, load it from the database. So here, I'm just going to say, okay, fine, I'll save it to the database. We also have the ability to shade that line. So here, I'm going to shade it. And with that saying, I'm just going to go back to a solid line. There you go. And now that line is shaded. I'll just make it a bit thicker so that we actually get to see what we're doing, what we're working with. There you go. I've shaded this one. I'm just going to get rid of silica for now so that we can have a better look at this line. So there we go. We've shaded the line. Now the shading, line shading, is not a premium feature. This one is actually a base feature. However, altering line shading to do more than what you've just seen is going to be premium. So we can alter the classifier. We can make it a quantized classifier, have 10 breaks. So basically what we're doing is that every color is going to be a categorized lot, and it's going to be decile per decile, for example. And I'll be able to change also the palette to something else. We ship CET palettes, Center for Exploration Targeting palettes. There's your regular, looking palettes like hot coal, the MATLAB ones. They exist within a framework made by the CET, designed to not fool your eyes. That's the short version of it. But basically, the Center for Exploration Targeting at the University of Western Australia has designed. They've designed color palettes that take into account the way our eyes function in terms of sensitivity to red, green, and blue, and how to prevent a color palette from making us see things that don't exist and making us miss things that do exist. So that's a very, very poor summary of this work. I can share the link to there's a whole thesis that was made on this subject, and they have their own website. But basically, that's what we do. And here, I can alter this palette, and we can see that it's basically become a discrete system. If I lower the number of breaks, it will make it more obvious that basically these are discrete colors. Or we can also, of course, display the legend. If you need the legend, you'll be able to display the legend in this case. On top of line shading, which I'll get rid of, and I'll also get rid of the line, we also have area shading, which works the same way, but for area shading, you'll have the same type of options. You'll be able to select another variable. By the way, I could very well select silica and say, I actually want aluminum to be shaded by silicon in this case. So you can do, again, just like we did with lithological data, with lithological intervals, you can basically swap keys within the same table. So you can do cross field symbology within the same table. And that is basically what you're able to do with this type of numerical data. You can, at any point in time, again, we can alter titles and all sorts of things like that. And we can also swap from line to bar chart if we want to, which is why I imported it as discrete data to showcase that we could go from one to another. Now, we don't have proper intervals in this case. It's just basically considering that every point measurement is going to be the centroid of one of the bars, basically on the bar chart. That's it. But basically, you can have bar chart representation if you're more comfortable with that. And again, we also have bar shading and bar pen, which works exactly the same way. I like to remove the bar pen for my bar shading. You don't have to, but I personally like doing that. And let's say I'm just going to actually save that style to the database. And the next step I'm going to go through is to actually project this onto the canvas, onto the map. And for this, I'm going to go and click project bar chart to canvas, and there's plan and effective. So I can choose whether or not I want to project this data onto the map. I can choose to project it onto this straight dashed line or the curvy solid line, which is the actual survey the projection. So I'm just going to click both of them and click project, and it's going to do its work and project it, onto the map. Now, there is, in some instances, there's a visual bug, which has been fixed already when it comes to that. From time to time, we basically get the LUT that does not scale properly, but no, actually I'm pretty sure I'm the one who's basically making the mistake myself, and it's here. That's the one. These are the advanced options. I was not willing to actually go that deep, but basically these are the advanced options, and the advanced option, this works also for any time you have to interact with a color, with a palette, is that you're able to actually set the breaks yourself if you need to. You can set them manually. You have access to all this data. Okay, to define the apply to all. And there you go. Now we get something that is technically, that is coherent with what we are looking at. And therefore, I will select this one instead. I will select this one whole, and that is going to be sufficient for us. There you go. All right. So in this case, what happens is that what we've just projected is going to manifest itself in the form of a layer. It's just a regular layer that you can interact with. Now, it is a bit laggy because I'm streaming this, but when you're running this on a proper desktop and or a laptop that is not a bit old like mine, you'll be able to you'll have decent performance. There's no problems with that. You can choose to display or not this layer. It is not some kind of drawing or some kind of decoration onto the canvas. It is a regular layer. This is something, by the way, that you'd be able to do using QGIS from scratch. And I believe Grant Boxer made some form of tutorial, or Mama Geospatial did, I don't remember, or maybe they both did jointly, I don't remember. But the reality is that yes, it can be done with Q by hand. It takes about half an hour, 40 minutes to get it to work right every time. And so what we've done is that we've automated it, and it can take this data straight from your database and just project it once so. When it comes to lithology, and let's say that's the database, I'm just going to get rid of that visually. So yeah, we can zoom in, and it's going to be actually be lined to follow the line. And if we do the opposite, there you go, it will follow curves. Now, of course, in some instances, you might end up with some kind of ridiculous looking kind of projection, but that's what cross sections are for, really. So you might end up with projections like this, and that's because the hole was mostly vertical, and so you get some kind of helicoidal pattern when you're trying to project the data this way. There really is no remedy to that on the map. It just means you have to look at it in a cross section, which we'll do shortly, but that's what it means. You have to have a look at it on cross section view. All right. Now, when it comes to lithological intervals. This is numerical data. We could have projected numerical data on the line itself, but basically what I'm going to do here, I'm going to get the left code again, and I'm going to select left code, and I'm going to do the same and project it onto the map. And there we go. We've projected the left code. So I'm just going to get rid of this and rid of that, and there we go. And you can see we've projected the lithological codes, intervals onto the map. And I can, there we go. We'll get there eventually. There you go. And so here's what we have. All right. So now, if we want to have a look at any one of these things onto the cross-section, we certainly can. We could be using the native tool, which is the elevation profile, geo-elevation profile. That one is part of Q. It is native, so it's already on your machine. If you have QGIS installed, I think it appears in QGIS 3.30, so or 3.28, but 3.30 for sure. There was the elevation profile. It hasn't evolved much, honestly, since, and it is not exactly suited for a geologist needs. So we developed our own. We ended up developing our own. We did fund this for quite a bit. We funded the development of this. Some of it was developed by Australia, but there's been some kind of, let's say, challenges with where the community wants to take this tool. And just so we're all aware of it, a geologist accounts for less than 2% of the user base of Q. So we are not exactly the priority of the QGIS community at large. GIS is extremely important for a geologist, but geologists ain't important for GIS people. You just need to be aware of that when you're wondering why OpenLog was not made much earlier than that, and why whatever base feature in QGIS is really not designed with geologists in mind, and you have to repurpose things that were designed for, say, civil engineering applications. That's because we are less than 2%. And that includes not just mineral exploration, it's geologists at large represent a very, very tiny fraction of the user base. Now, to use our own cross-sections, which are part of the premium package, well, you can go to OpenLog and click cross-section. And there's going to be a widget that is going to dock itself at the bottom of the screen. You can move it, by the way, from this, I've been doing this demonstration of single monitor. This panel, the dev data panel that we've been working with for a while, is something that you can undock and move to another screen. It is what it was designed. This is how it was designed to be used. If you have dual monitor setup, it will make your life much easier. You'll be able to pull it and not have it in the way. Obviously, in the case of demos, that I don't have that luxury, so it sometimes looks a bit crowded on my screen. But you are able to work to have a more, let's say, rational workspace when you're not doing what I'm doing. So at this point, we have the cross-section. I'm just going to click the second button, which is to create a section line, and I'm going to be able to say, make a cross-section, which is going to be kind of nonsense. It doesn't matter. Just make a cross-section. Just as with the base tool, you can have multi-panel cross-sections. Unlike the base tool, we actually are honest about what they do. So there is this void here, and that makes sense. That is because you're basically stitching to orthogonal projections. So you won't have sort of singularity happen at this stage. When you are working with the cross-section, there'll be an indicator that tells you where you are. You can actually alter the projection distance with a mouse, and it will update in real time, basically. You can of course alter these parameters directly with this window, and you can also actually move the cross section around on the basis of a step, or I could simply drag it around if I wanted to. So these are features that are not found in the base tool. There is options to add a panel and to break a panel. I can split a panel if I needed to, right? And I can, once I split that panel, I can actually get rid of that vertex, right? So you've got options to actually work with. If you needed to input, to input the vertices, trace vertices manually, you can input them manually. Yes, you'll be able to import it from, say, a full align layer. We are looking to be able to do that. This will be available in the next version. And you'll also be able to save cross-sections to the database such that when you close Q or when you close your database, you disconnect from your database, the cross-section does not disappear. This is what we're working on for the next version of the OpenLog. Actually, it's already implemented. It's just it's not in the production version. And this demo is the production version. It's what you are able to use right now as a premium user, rather than what I have running on my own dev environment. Now I just hit save. I'll just make that cross section. That's fine. We've got vertical indicators for the cross section. I'm just going to make it a bit more, a bit larger. It's going to project any number of DTMs that you have, or rather rasters. If you have any raster layer, it will project onto the cross section. So if, say, you were working in an open pit environment, if you want different pits over time, you want the outline of these pits over time, yeah, you'll be able to have that on the screen. We have on the side, you can deal with the different layers independently from the layer widget, which means here I'm able to say, I want to remove the plan, to remove everything basically that is planned effectively. This one, for example, and well, actually I'm going to get rid of this, just lots of data here. You can add and remove layers from the layer widget. You can add and remove them from the cross section, and you can reorder them to make sure that so you don't have to follow the layering, the hierarchy of the map onto the cross section. You can set it the way you see fit, and we can of course get rid of this panel. Useful options include here, and you can see that is this indicator, that is telling you of the actual easting, northing coordinates, as well as the actual depth and the distance along the cross section. But this will make it more obvious once I display the UTM coordinates for every vertex. So the vertices are now located. We've done this such that a user could simply make a screenshot of a cross section, and another person would be able to actually place this cross section on the map. And the same thing goes with the panel orientation. You can have the orientation of every panel onto the panel. You can add a grid, and that grid can be set to either display relative distance along the trace, or absolute coordinates, so UTM coordinates, right? And you can actually swap that cross section around, such that if you're looking at, in this case, from the south, I can choose, basically southwest, I can choose to look at it from the northeast side. So I can do this, and it's going to swap it around. And effectively now we're looking at it from the other side, and it will update the panel orientations, right? We've got 306.7, 274, and we swap it around. We've got in 180, we've done a 180. So to 94 and 126. You can always alter the projection distance like this just by using mouse 3. You can scroll your mouse. And at any point in time, if say you're away from your section, you can just zoom back to the section. And if you kind of bothered by the outline, you don't have to have the outline. You can get rid of the outline. If you want to make a screenshot for some kind of marketing material or an internal report and you don't want the outline, you can remove the outline. Or it's just annoying you for any other reason. You're interacting with it. when you're trying to select another layer, that's fine. Just get rid of the outline, and then it will allow you to interact with the objects more easily. So this is a cross section. This is one of the latest tools that we've developed with quite a bit of effort into that. You can also swap from the aspect ratio of your cross section. You can go 1:1 or whatever aspect ratio the aspect ratio of the widget itself is. And that's pretty much what you're able to do with cross sections. And as we've demonstrated, yes, we are able to display. I was not on plan. I was on effective. Oh, so let me. Yeah, and I'm going to get rid of mythology in this case. I'm going to get rid of the trace, and I'm just going to zoom in. There we go. So you are able to display this type, to have this type of cross section directly in Q without too much trouble. Now, it took 2 hours to get here with a lot of talking, with a lot of nitpicking things and digging into things. The reality is that it doesn't take too long actually to get there. When you know what you're doing, you can get to this point within 10-15 minutes, really, even less for some power users I've seen. So this is where the demo for OpenLog is going to end. There's lots of other things that we can do. If you wonder if we can display several, numerical data series on the same graph. Yes, we can. This is done with data composition, which I haven't really had the time to delve into and which we won't delve into, but this is where you're going to be able to display multiplot, crossplot, stacked bar charts. This is where this all lives, and it's also part of the premium package. And this is working with stacked bar charts is useful for mineralogical proportions. And of course, yeah, you can crossplot and crossplot numerical series against one another within a hole or across holes. And we can also have multiplots, and it works even with heterogeneous series. So basically, if your series don't have the same units, you'll still be able to plot them on the same downhole plot. We also have tools, and a useful tool is to define local grids. If you want to define your locals and a local CRS, this is something that can be done too. And you'll be able to do it either by defining an origin and a direction, or have reference points. Origin and direction means basically you click on the map and you say, this is my 0, 0, and this is the orientation of my X and Y axis. And I want everything to be projected according to this local grid. This allows you to, and will generate a WKT file, which will then you'll be able to reuse in any number of QGIS projects, or even with other software. WKT is an open standard for CRS. CRS definitions. And of course, you can also, there's options to manage your data and options to, so for example, I could, if I wanted to, alter the database from the manager. Again, this is also a premium feature that you're able to add tables, add fields, remove fields, alter the content. All of this can be done from the downhole data, manager. When it comes to import profiles, I've discussed import profiles. It's basically something that allows you to automate, to semi-automate or fully automate an import. So once you've set up an import profile, you can reuse it manually, or you could have a scheduler. You could schedule an import. And when you schedule an import, you can define whether or not you want new data to merge with existing data, to overwrite existing data, to merge right, merge left, ignore. There's plenty of options for doing that. And then you could be adding colors. Now, adding a color by hand is useful for planning. You can do it by point and clicking colors, or you can do it on what we call on grid mode, which lets you define a grid of points, set spacing, set orientation for your colors, and then place them on the map.